So welcome back. We were just discussing how to reduce the dimension of the system. So let me share my screen now again. Okay, so from the market clearing condition for the goods, we have this result. So what did I do? I just moved the intermediate input demand on the right-hand side. So then I rewrite this in terms of this. Okay. So here, as you see, I have a square matrix here and a vector here. So what can I do here is this. I'm going to multiply each side of this equation with the inverse of this matrix. Okay. So I have In minus A inverse consumption demand P star omega star. Okay. So notice that this is just equal to the identity matrix itself. Okay. So then I have Y star equals In minus A inverse consumption demand P star omega star. Now this is called, in some resources, this is called the Leontief inverse. Oops. And of course, we want this to inverse to exist, right? So if the computer does find this inverse matrix, then I express Y star as a function of prices. Okay? And be careful, I multiply this from the left-hand side. Okay? Because this is a matrix, this is a matrix. So I have to multiply it by the left-hand side. All right? So another equation we had was this. Omega star V plus P star A equals P star, right? So now again, be careful. This is a row vector, one by n, all right? So this is 1 by n, this whole thing, and this is 1 by n. Okay, so you can write this in this way, equals P star minus P star A. At that point, it is still 1 by n, right? But now realize one thing. This should be written in this way, right? Because this is 1 by n, and this is n by n, right? So this whole thing is again 1 by n. If you write it in this way, so you have PVA, the price of value added, times V equals P star In minus A. All right. Now, how do I find P star? I have to multiply both sides by the inverse, by the Leontief inverse again, but from the right-hand side. Minus A inverse. You see, I'm doing it from the right. Okay. So then I have P star equals price of value added times V matrix times the Leontief inverse. Okay. Now realize that I expressed P star as a function of omega star only. Okay. So I have this, and I have also y star equals y p star omega star from the earlier derivation. Then now I can mix all it up. Where? Here. Remember this equation? Now I have what? I have p star as a function of omega star, okay? And I have y star as a function of p star omega star. But then I also have, so this is omega star, z omega star, careful here, y p omega star, and this is now a system that has k equations and k unknowns. Okay? The condition I need is that this inverse exists. Okay, so I assume that this inverse matrix exists. Okay? So then I express my system. So I reduce the dimension of the system from 2n plus k to k. Then now, because of the Walras law, I'm going to say, let's say omega 1 star is equal to 1, or I'm going to say from k equal to 1 to big K, the sum of omega k's are equal to 1, or something like this, okay? Some price normalization. So this will be my new equation, and I'm going to drop one of the equations here. Here. Okay? Then I will have, again, k equations and k unknowns, but one of the markets will be cleared by the Walras law automatically. Okay? So that's the idea. That's the notion. All right? So do you have any questions so far for this model in chapter 3? So remember, we have more than one produced good, more than one primary factor. Households, they own these primary factors such as land, labor, capital. They can use some of these factors by themselves, or they can sell all of it. It depends on their preferences. So households determine their consumption demand and factor supplies. All right? Then firms, they solve a two-step problem. In the first step, they want to optimally hire the production factors, land, labor, capital, etc., for a particular production size, production capacity. Okay? Then they're going to find their optimal demand for intermediate inputs to produce a particular amount of the final good. All right, that final good. In our example, remember, it was burgers. So first they open the restaurant. So they need land, they need labor, they need capital. After opening the restaurant, they have a scale. Now, depending on this scale, this V parameter, remember, they hire, they purchase intermediate inputs such as bread and meat and tomatoes and mustard and mayonnaise, etc., etc. Then they minimize their costs. Okay. In a competitive equilibrium, such as this one, under constant returns to scale production function, obviously, we have a zero profit condition because this is a competitive economy. So so how much firms will produce will depend on demand, right? At a particular price. So our system will feature unknown product prices, P1, P2, Pn, unknown factor prices, omega 1, omega 2, omega k, and unknown production levels, output levels, Y1, Y2, Yn. So we have this 2n plus k equations and 2n plus k unknowns. Then we reduce this system by eliminating P star and Y star. So we expressed our equilibrium conditions only in terms of factor prices, and then we realize, of course, one of these prices, so one of these markets, one of these factor markets will be cleared by the Walras law. So we eliminate this market and we introduce a price normalization. So once again, we have k equations and k unknowns. Okay, so that's the entire thing that we did. So if you have questions now, you can ask me, or I can show you an example. Okay, then so this example is directly from your textbook. Let me quickly go over it so you can also see it in the text. I will not spend a huge amount of time on this. So this is a simple example from your text. So here we have two consumers, so two firms, two consumers, and two factors. Oh, all right. Okay, sorry, I forgot. Where is that? Okay, so we have two firms that produce final goods. We have two consumers, and we have two primary factors. Okay. So for consumers, we have Cobb-Douglas utility functions. Let me write them. U1, C11, C21 equals C11, beta 11, C21, beta 21. Okay. And for the second consumer, we have C12, C22. So C12, beta 21, C22, beta 22. All right. So these values are, so beta 11 equal 0.3, beta 21 equals 0.7. Let me check. Beta 21, sorry, beta 12. This one is beta 12. Yeah. Sorry, what now? Beta 12. Oops. Uh, 0.6, and beta 22 is 0.4. All right. Then you have the endowments. For the first consumer, you have E11, E21, and these are 30 and 20. For E2, you have, of course, E12 and E22, and these are 20 and 5. Okay. So now you can express the problem, right? So maximize UH, so H, so here we have H12, right? I12 and K12. So you have C1H, C2H. Okay, you are maximizing by choosing consumption levels subject to your budget constraint. So your budget constraint is like P1, C1H, P2, C2H will be equal to omega 1, E11, omega 2, E12. So E21, sorry. Okay, that's it. So this is a Cobb-Douglas problem you can very easily solve. Okay, so you express your solution then for any good and any consumer, right? As a function of prices in the product markets and prices in the factor markets. Okay, so that's simple. Then you have the production side. First, we have the input-output matrix. So this is, remember, A11, A12, A21, A22. And don't forget the interpretation. Interpretation is this. To produce Yj units of good J, you need Yij units of good I. Okay? Let me write it. So to produce 1 unit of good J, you need Aij units of good I. Okay, so that's the interpretation. And in our numerical example, these are 0.2, 0.5, 0.3, 0.25. Okay? So that's there. Then we have the value-added production functions. So for VA1, we have mu1, mu is a parameter here, x11, alpha11, x21, alpha21, right? Yes. So here, alpha11 is equal to 0.8, alpha21 is equal to 0.2. So as you see, it is constant terms to scale, right? And for the second firm, we have mu2, so mu1 is greater than 0 here. So we have x12, alpha12, x22, alpha22. So alpha12 is 0.4, alpha22 is, of course, 0.6, right? Because it is, again, CRS, and we have mu positive, all right? Then, for each firm, we have to specify these technical coefficients. So these are equal to these. All right, remember, these are to convert from value added to output, right? So at the end, then, we can write this. Y1 is equal to minimum of VA1 0.5, Y11 0.2, Y21 0.3. Okay, so here we wrote this for J, right? So be careful. This J here is this same J and this and this. Okay. So for the second firm, we have the similar thing. So it is VA2 divided by V2. V2 is 25. And then we have Y12 0.5, Y22 0.25. Okay, now you realize this J is equal to 2, J is equal to 2, J is equal to 2, J is equal to 2. Okay, that's it. Then you solve it. It's very simple. At some point, so let me show you the solution. Then you do it by hand, okay, at home. So the solution is like this. If you solve the consumer problem, you have this. Right? a fraction beta IH of your total income is spent on the ith good. Okay? This is the Cobb-Douglas solution. Then, for the firm's problem, it's of course a bit long, but you can do it because I showed you how. You're going to find this. This is just simple microeconomics. So this is 2. No, I'm doing it wrongly. Okay. Omega 1, alpha 1j, omega 2, alpha 2j, VAJ. Okay. So here we have, so this is true for both J's, and this is true for both goods and both consumers. So here there is a trick for simplicity and without loss of generality, we equate this to 1. Okay. I will explain in a couple of weeks why we can make such assumptions. All right. This is about the measurement units. If you look at the production function here, where's that? Okay. So not this one. Not this one. Yes. So if you look at this, these mu parameters are basically about the measurement units. So how do you measure the product you produce? I mean, is it kilogram or gram? So what's the measurement unit? So since we can play with them, I will show you how in a couple of weeks when we start thinking about the measurement issues. You will see that we can make such simplifications. All right. But what do I see here? So remember, this is the total cost, right? The total cost of value added. So producing 1 unit of value added will cost this firm by this amount. So this depends on factor prices because the firm will use 2 of these factors, factor 1, factor 2, and then production function parameters, of course, will affect, right? Will affect what is the optimal cost. Remember, there is this ISO product line, and the firm minimizes the cost right here. Okay. So obviously, the curvature of this function is important. All right. So that's the cost. Then you have x1j. Remember this result. Omega 1. All right. And similarly, for x2j, you have the cost function again. And this derivative. All right. Then this thing this derivative, these derivatives, oops, sorry about that. So these derivatives will give you what? Will give you B, right? B1J will be equal to, so this derivative, let's do this. Let's do this. So if you take this derivative, what do you find? Let's look at one of them. X1J will be equal to what? This the derivative of this with respect to omega 1, right? So you have alpha 1J, omega 1J, alpha 1J minus 1, omega 2J, alpha 2J times VAJ, right? Now this, if you remember, is your B1J, okay? Yes. So then you have B2J. You can also find B2J here. So these are the how much factor 1 would you need to produce 1 unit of the value added? Okay. How much of factor 1 would you need to produce 1 unit of value added if you are doing it optimally, obviously. Okay. And then the price of value added is already here, right? So the price, so this is itself the price of value added, as you know. Okay. Okay. So how much time we have? Okay. So do you have any questions?
Not now.
So it looks a bit complicated, yes, again, because you have too many factors, you have too many goods, you have too many firms. But if you write the 2x2x2 version, right? If you write the 2x2x2 version, so 2 households, 2 firms, and 2 factors, you can actually do the math, you know, simply, not requiring too much stuff. There is also a numerical example, okay, in the text. So I will leave that to you, but there's only one thing there. So they solve this model using GAMS. So they look at an equilibrium like this. All prices are equal to 1. Okay. And production levels equal to 100. Okay. Now, if you do the math, you can eventually actually solve this system by hand. Okay. Because this is a simple version. But the idea is to use, of course, a computer program to do it. Now, that type of a computer program is called GAMS. Okay, General Algebraic Modeling System. Okay. Now, GAMS eventually arrives at this equation. Okay, remember this equation. Okay, and this is a nonlinear. So this is a system of nonlinear equations. So we use GAMS to solve this system, and of course they calibrate. So there's calibration involved in this particular solution as well. But after the midterm exam, I will show you exactly how we do it in GAMS. So it would be very nice if you install the student version of GAMS. The student version of GAMS is free. It is very easy to install. There's no fancy stuff. So just install the GAMS to your computers after the midterm exam and look at this numerical solution in your textbook. Okay, we're gonna study exactly this solution after the midterm exam. Okay. So now I can answer your questions and respond to your comments. Again, I will upload past exams for you to look at, and then I will do that for the other class for development as well. Then you will have 24 hours for submission of the midterm next week. Okay, the floor is yours. Go ahead.
I have no question right now. I have to study first.
You have to study first.
Yes.
So should I understand from this statement that you haven't been studying up until this
No.
point?
I have studied, but about this lesson, I'm not able to ask questions.
It is not all that difficult, my friends. Just, sit down with pen and paper and the textbook and the lecture, and you do it by your hands. Then you understand the logic of it. Okay? By taking these derivatives, by looking at the definitions, by taking these derivatives, you start understanding how we can, for instance, define price of value added. How we can define the unit cost of, let's say, value added, etc. Okay? So it all depends on your effort, obviously. I mean, it should take time. Okay, then. So if you have nothing, then I'm going to end this meeting and upload the lecture to Huza. All right. So next week, there's no class. This is the midterm exam week. Our classes will resume in 2 weeks. Okay. Then I will see you there. I am ending the meeting now.
Have a nice day.
Good luck in the exam, and in all of your midterm exams. Study hard, and take good care of yourselves. Okay, bye bye.
Görüşürüz hocam.
Görüşürüz hocam.